Yes, sir. Started.
Okay, so this is our fourth module. One second. So, good evening, Ramchand. Today we are going to start module 4, that is called data structures. How this data structure is going to help us as a data scientist if you are working in the domain of data field and databases and data science. So, how this data structure will play crucial role for implementing any real-time applications, the way you are choosing the algorithms, how best algorithms you are executing, what is the time complexity and what is the space complexity it is occupying. So in this module, we are explaining 14 topics like introduction to data structures, like data structures is a systematic way of organizing data and accessing the data and representing the data in any fashion, like linear fashion, non-linear fashion. Linear fashion with the help of arrays, stacks, queues, linked list we are performing, and non-linear data structures like trees and graphs. So there are two types of data structures. One is linear data structures and another one is non-linear data structures. How can you define linear data structures? Linear data structure is a structure which comprises um, it is a systematic way of organizing data and storing the data and representing the data and retrieving the data in the fashion of linear, sequential. That is called linear data structures. Examples like arrays, stacks, queues, linked list. Examples. Then we are going to see the second type of data structure is called non-linear data structures, a systematic way of organizing data, storing the data, representing the data, and retrieving the data in the fashion of non-linear fashion, that is hierarchical fashion. Examples are trees and graphs. So why should I study these data structures? There are four advantages of studying data structures, like efficient storage purpose. We are studying data structures. Efficient retrieval, efficient storage, efficient retrieval, and efficient choosing the best algorithm, and these are the great advantages of data structures. That's why we are choosing what type of data structure is suitable in order to implement real-time applications. Okay, so best examples we can see the concepts in data structures, stacks, queues, linked list. These are the linear data structures. Why, Ramchand, these are the linear data structures? Any reason?
Uh, some.
The way we are performing operations in sequential manner, that is the
Okay,
answer.
sir. Okay.
Linear fashion, you need to tell.
Okay. Okay, sir.
Okay? Ramchand, are you getting my
Yes, sir.
point?
Yes.
Okay. So give examples for linear data structures.
Stacks.
Very good.
Queues also,
Queues,
sir.
link, queues, linked
Okay.
list. These are the data structures are used under linear data structures.
Okay.
Okay. What about non-linear data structures? A systematic way of organizing data and accessing the data in the fashion of non-linear fashion. That is hierarchical pattern.
Maybe trees are the
So
example.
there
Trees are the example.
trees and
Okay.
graphs. Graph.
Okay. Okay,
Okay.
sir.
So Then advanced data structures like hash tables we are studying, and advanced trees we are studying like binary search trees. And there are four approaches usually we are using in data structures, like divide and conquer approach, okay, and greedy approach, dynamic programming, and branch and bound. So these are the four approaches we are using in data structures, and the two types of data structures like linear and non-linear. Linear examples like stacks, queues, linked list. What is meant by stack? The how it is working. Stack is a linear data structures and follows the principle last in first out. Okay, LIFO. And stack operations like push, pop, and display. Peak also operation. So these operations, how it works, and we will see one program. Okay. So stack uses linear data structures and follows the principle last in first out. Then queue. Queue is a linear data structures and follows the principle first in first out. Examples like if you are standing in a queue for cinema tickets, who is the first person, he will get first tickets. That is first in, first out. That is called queue data structures. What about stack? Last in, first out. Suppose if you see idli plate container, how it is working. The first you kept idli container, there are three layers are there, you know,
Yes,
Ramchan,
sir.
idli. So the first you kept and you are removing last. The last you kept, you are removing first. That's why last in, first out. LIFO. What is the principle of stack?
Last in,
LIFO.
first out. Whichever is kept last is taken out first. Whichever is kept first is taken out last.
Very good. What is the principle of queue?
In
First
a queue,
in.
first in, first out. In a queue, the first person gets the first ticket. The last person gets the last ticket.
Perfect answer. Next, there are next linear data structure is a linked list. How simply you can remember, you can listen my definition. Linked lists are linear data structures. Linked lists are three types: singly linked list, doubly linked list, and circular linked list. How can you define a linked list? Collection of nodes and connected by the links in one direction is called a singly linked list. Collection of nodes and connected by the links in both direction, that is called a doubly linked list. Next, collection of nodes, the last node is connected to the first node, that is called a circular linked list. Are you
Yes,
understanding?
sir.
Okay, what is mean by node? Node is a combination of value and address. Okay, node is a combination of value and
Address.
address. Collection of nodes and connected by the links in one direction is called a singly linked list. Doubly linked list, how you can define? Collection of nodes and connected by the links in both directions, that is called a doubly linked list. Circular linked list, how do you can calculate, how do you can define? Doubly linked list is a collection of nodes and connected by the links. The last node is connected. Okay, the last node is connected by the
First node.
first node. The last node is connected
By the
to
first
the
node.
first node. That is called, yeah. The last node is connected to the first node. That is called
Circular.
circular queue. So these three are linear data structures. Now trees. Tree is a non-linear data structures. How you can define a trees? Collection of nodes and connected by the links in a hierarchical structure, and it follows the root node and followed by the children nodes. That is called trees. Okay, node is a combination of value and address. Keep in mind. Next, hash table is a you can call it as a linear data structures only. Hashing is a process of mapping key with value. That is called hashing. Hash table is a collection of elements we are arranging in a index positions. Index positions. Index of 0, first element. Index of 1, second element. Index of 2, third element. Likewise, buckets. Bucket 0, first element. Bucket 1, second element. Like that, we are arranging the elements. Is called hash tables. Why we are using hash table? It is very easy to searching concept is very fast in a hash table comparatively other concepts. Searching algorithms are two types. We are searching element is presented in the database or not. That is called searching. There are two types like linear search and binary search. Linear search is a type of searching algorithm. We are searching elements, sequence of items in a given data set. That is called a linear search. The time complexity takes order of n. Suppose n is equal to 5. What is the time complexity, Ramchan?
Yes, sir.
What is the time complexity of order of n is equal to 5 elements are there? What is the time complexity? Order of
Order of
n.
n.
That's
Okay.
all. Yeah, but because it is a linear data structure, it takes time 5 steps. Suppose the last element is searching, our searching element, it takes 5 steps.
Okay.
Okay, that's why it is called a linear data structures. What about a binary search? Binary means 0 or 1.
5 of
So
n by 2.
binary, yes, yes, log of n by 2.
Okay.
Order of order of
Log of
log
n
of
by 2.
n by 2. Yes, because it reduces the process. Binary search is a searching algorithm. First, we are selecting the middle position of the element. Okay, and our searching element based on searching element, if it is less than, you are avoiding second portion. If the searching element is greater than the middle position element, you are leaving first half of the portion. That means suppose n by 2, order of log n by 2.
Okay, sir.
Half of the time we are reducing a comparatively linear search. That's why binary search is better than linear search. Then sorting, arranging of elements in any sequential order, ascending or descending. That is called sorting. There are so many techniques, sorting techniques, but I am explaining 5 important sorting techniques like selection sort. We are selection sort, bubble sort, insertion sort, merge sort, and quick sort. Okay, these are the sorting techniques. So selection sort says that select a minimum element, compare with the other elements. That is called a selection sort. Bubble sort is a exchange sort. So first two elements you are comparing. The first element is less than the second element, keep it same. First element is greater than the second element, you can swap it. That's why it is called exchange sort. Then insertion sort. We are inserting minimum element in between two elements based on our convenient. Then merge sort and quick sort comes under divide and conquer approach. So I have explained already 4 types of approaches of data structures. Okay. Divide and conquer approach, greedy approach, dynamic programming, branch and bound. So here dynamic divide and conquer, if we are getting very large problem, big problem, and we are dividing into two groups, okay, small subsets, then we are sorting subsets, then we are making finally merging. That's why it is called a divide and conquer approach, merge sort. So based on our requirement, we are dividing into groups. That groups are minimum subgroups. Each subgroup we are arranging the elements, then we are making into sorting elements. That is called merge sort. Quick sort is the best algorithm comparatively all other sorting algorithms. Why? The name indicates that quick sort, there is a pivot element. Pivot means important element. We are choosing any element as a pivot in a given list, and we are comparing with the left I with pivot, left right j with pivot. At a time, left with I, right with j to the pivot element at a time. Simultaneously, we are performing left to pivot, right to pivot. So half of the time complexity we are reducing, because at a time we are checking with left to pivot and right to pivot. That's why quickly we are achieving the arranging elements based on the pivot concept in quicksort. Quicksort is a partition exchange sort, usually we can call it as. Then graph. Graph is a collection of nodes and connected by the links in circuit format, is called graph. What about a tree? How can you define tree? Collection of nodes and connected by the links in hierarchical pattern. That is called a tree. Graph. Graph is a collection of nodes and connected by the links in a circuit format. There are two types of graphs are very important. Like DFS, I mean BFS and DFS. Before going to graphs, I need to explain trees. Tree is a collection of nodes and connected by the links in a hierarchical structure. There are many types of trees like binary tree, binary search tree, red block tree, split tree, like that. But we are discussing about binary tree and BST, binary search tree. Okay, so binary tree is a tree having at most two children per a root node. That is called binary tree. And binary search tree is a tree. The first element, we are choosing the first element is a root element, and we are comparing with the next element. If it is less than, keep it left. If it is greater than the root node, keep it right. So this based on this property, we are arranging the elements in binary search tree. Once again, binary search tree is a tree. The first element we are choosing a root node. Next element we are comparing with the root node. If it is less than, keep it left side. If it is greater than the root node, keep it right side. That is called a binary search tree. How can you justify binary search tree is correct? Once you are connecting, once you are performing tree traversal algorithms like pre-order, in-order, post-order, and level order, the way we are getting elements for in-order traversal, like left to root to right. Like that, we are getting the elements. Then we can justify the constructed BST, means binary search tree is a it is a binary search tree. Then we are moving to graph. Graph is a collection of nodes and connected by the links in a circuit format. There are two important graph traversals. In graphs, we have directed graph, undirected graph, weighted graph, like that. Two types of graph traversals like BFS and DFS, breadth first search and depth first search. In depth first search, we are using the principle of data structure is stack. And the BFS, it uses a queue principle, first in, first out. DFS uses stack, it uses LIFO, last in, first out principle. So this is about the data
So the
structures.
DFS
Now,
DFS follows the Q principle,
Stack.
stack.
Stack data
Okay,
structure.
BFS.
Because height based on the root node to next children nodes, it will grow like depth first search means it uses a stack principle, whereas a BFS it uses Q principle, first in first out principle.
Okay, sir. Okay, sir.
Okay. So now I'm moving to concepts like what is programming? Program is a collection of instructions. What is meant by instruction? Instruction is a set of rules, regulations. Collection of programs is called software. We have two types of software, system software and application software. System software, it is example like operating systems. Operating systems is operating system is a software, and it is interaction between user and a hardware, like two types of operating system, like Windows based operating system and command based operating systems. Windows based operating systems are very easy to navigate because of graphical user interface, like Windows 2000, Windows 2007, 2014, 10, etc. Whereas a command based operating system like Unix, Linux flavors like Ubuntu, etc. So application softwares are different. Like in banking system, we are using so many applications. Then the process of designing, writing, testing, and debugging, and maintaining code that computers can execute is called programming. Designing through diagrammatic representation, through writing, we are writing a code, testing the code. Debugging means eliminating the errors in a software, and maintaining code that computers can execute is called programming. Any term if you are not understanding, please ask me,
Yes, sir.
Ramchan. Are you familiar?
Yeah, let's go ahead, sir.
No
No.
problem. Are you understanding very
Yes, sir.
well? Okay, so programming is used to solve problems and automate tasks by using languages like Python, Java, and C++. One common thing is there in three languages. What is the common feature?
Object oriented.
Can anyone? Perfect, perfect answer. It is both languages are object-oriented programming languages. Python is developed by Guido van Rossum. He is from Netherlands in the year 1970s. Java is a object-oriented programming and internet-based language. It is developed by James Gosling in the year 1995. C++ is developed by Jarn Strostrup, be silent, Jarn Strostrup in the year 1983 in order to avoid the drawbacks of C programming. And Jarn Strostrup invented C++. One plus indicates object-oriented features and one plus indicates C features. That's why C++. Then types like procedural language, like C is a procedural language, and Python, Java, C++ are the object-oriented programming languages, and functional and scripting. Functional. C is a functional, C++ also functional programming language. What is the meaning of functional? We are using two types of function in a program, like predefined functions, user defined functions. What is meant by function? Function is a set of rules to perform specific task, or function is a self-contained block of statements to perform specific task is called function. So if you take C, C++, we have a number of predefined functions like printf, scanf, clr, scr, getch, and absolute, square root. These are the predefined functions. What about user-defined functions? We are define users can define their own functions like big, small, GCD, factorial like that. Then that's why C and C++ is a function oriented programming language. What about a scripting programming language? Python is a scripting programming language because we are writing our own script. Python can be executed in two ways.
Yes,
Ramchan,
sir. One is through script, other one is
what
through command prompt.
perfect IDLE and a scripting way you need to tell.
Yes, sir.
Okay, what is the meaning of IDLE?
Integrated Development Learning Environment.
Perfect, perfect answer. Then what about scripting
Uh,
way? We are writing our
yeah,
own code.
with a notepad, we write the script and then compile with the help
Ah,
of command
not
prompt.
only Notepad for any PyCharm,
Google Colabs.
Jupyter. Ah, yes, yes, perfect. Then we are moving to examples. Writing a Python script to scrap data from a website. Yes, that is one example we can do. Then instructions to introduction to data structures. I have defined already, Ramchan. Can you remind me what you understood the data structures?
Okay. Data structures are specialized formats for organizing and storing data. In the sense, generally we have
Yes,
data in structured and unstructured way. Depending upon our
correct.
requirement, we use different types of data like linear, non-linear. If it is linear, then we use stacks, queues, linked list. If it is non-linear, we use trees and graphs. Um, yeah.
Perfect answer. Perfect answer. That's why data structures is a powerful. Why we are using data structure? Efficient storage purpose, efficient retrieving the element, efficient insertion of element, and these are the great advantages of data structures. So data structure is a systematic way of organizing data, storing the data, and retrieving the data, and representing the data in the form of linear, that is called linear data structures. Examples like arrays, linked list, stacks, queues, etc. The systematic way of organizing the data, storing the data, representing the data, and retrieving the data in the fashion of non-linear. That is called non-linear data structures. Examples, trees and graphs. Using an array to store student grades. That's why data structures playing a vital role. Next concept, stack. What is meant by stack? Stack is a linear data structures and follows the last in first out. And the concept used in various applications like undo. Yes, undo mechanism in word processing. You know what is happening undo operation in MS Word? Ramchand, can you explain?
It goes back to the previous step.
Correct. That means last performed action will get into the first. Last in, first out.
Okay.
Okay. So parsing expression like A plus B. Parsing tree, if you construct, there also it uses last in, first out. Then what about types of stacks? Array based stacks and linked list based. Yes. Write a Python program to implement stack using arrays. Write a Python program to perform stacks using linked list. Okay, so these two types we are executing. Then example, managing undo operations in a text editor, that is called stacks. Then coming to queue. Queue is a linear data structures and follows the first in first out principle, and and used in scenarios like task scheduling, printer queues. Suppose you are giving print option, so how it will take print option? Who suppose there are 60 students are there, so 60 students are okay, 60 students are giving print option. So they are getting print. Who gave first option? That is the person will get the printout first. That is called uh, first in, first out principle. like types like linear queue, circular queue, priority queue. There are types of queues are linear queue. It uses first in first out. Circular queue. It also uses first in first out. Priority queue, best in first out before. Then examples like task scheduling in an operating system. How operating system works, whatever the task if you are performing, first it will get executed. Then linked list. I have already explained linked list. List is a collection of elements.
Yes,
Ramchan,
sir.
list is a collection of elements. Linked list means collection of nodes and connected by the links in one direction is called a single linked list. Then collection of nodes and connected by the links in both direction, that is called a double linked list. Collection of nodes and connected by the links, the last node is connected to
First
the
node.
first node, is called a circular linked list. Okay, then sequence of elements we are arranging mm, uh, with the elements. Each element points to the next one, unlike arrays. So linked lists are to overcome the drawbacks of arrays. That's why we are choosing a linked list concept. A music playlist where each song points to the next song. So that is the best example for a linked list. Then trees. Tree is a collection of elements and connected by the links in hierarchical data structure with a root element and subtrees. So used in databases, file systems, and sorting algorithms, etc. Trees are various types like binary trees, AVL trees, B trees. Binary tree is a tree having at most two children. Okay, that is called binary tree. AVL means Adelson Welsky Landis. Tree scientist has been proposed AVL trees. It follows the principle, binary search tree principle. The left node is always less than the root node, and the right node is always greater than the root node. That is called AVL trees. AVL trees is nothing but the height of left subtree minus height of the right subtree equal to 1 minus 1 0. Like it satisfies that condition of a given any BST is called AVL tree. What is meant by BST? Binary search tree. Binary search tree is a tree. The left subtree is always less than the root, and the right subtree is always greater than the root.
This is very similar
That is
to
called.
AVL tree, also the same, no, sir?
AVL tree also uses BST, but additional in AVL tree, left subtree height minus right subtree height equal to 0, 1 minus 1. It has to satisfy that extra condition.
Okay, sir.
Then only you can say it is called AVL tree.
Okay, sir.
You
Yes, sir.
understand? No
Fine, sir.
problem.
Fine.
Then B trees. B, most of the people believe that B stands for balanced trees. So it is a B trees. Usually we can call it as a balanced trees. We are using in insertion of data in server system and data center by using a DBMS concept. We are studying B trees and B plus trees. For efficient storage and retrieval and insertion purpose, we are using B trees. All the leaf nodes are at the same level, and it has to satisfy the property of BST, binary search tree. Okay. So what is meant by binary search tree, BST? How can you simple you can explain? Left subtree is always
Less
less
than
than
the
the
root, and
root.
then the right subtrees are always greater than the root.
Yes, that is called
Search
binary
tree.
search tree. Once you have constructed with this principle, still, how can you justify the constructed BST is true based on the in order traversal?
Okay.
What is in order?
Uh,
Left, root to right.
okay.
Keep in mind.
Left to root, right. Okay.
That is called in order traversal. Pre-order means
Root,
root must be
root,
first. Root to left.
sorry, right,
Root to left to right.
root, left to right.
Left. And post order,
Post order is
left to right route.
okay.
Post means last route.
Okay.
Left to right route.
Okay.
This subject is in my fingertips, my favorite
Oh,
subject,
great, sir. Okay,
Ramchan.
sir.
Yeah, because I like this subject. I started my career with the data structures
Okay,
only.
okay.
In the year 2000, I started my career as a teaching.
Okay, okay.
24 years completed. This is 25th
Oh,
year. Still same subject is running.
okay.
Great,
Ah,
none.
yes, sir.
And next, organizing folders and files in a file system. In trees, we are using so many concepts. Next, moving to hash table. Hashing is nothing but a process of mapping key with value is called hashing. Hash table is a collection of elements. In a index based, we are storing the elements. Index positions bucket 0 to bucket n. So hash table is a linear data structures and a data structure for fast data retrieval comparatively other searching techniques. It uses a hash function to map keys to the indices. Indices means index position. A of 0, 1, A of 1, 2, like that in an array. There are types of hash tables like chaining method, open addressing method, and examples like storing and retrieving phone numbers by name. That is best example for a hash table. Then searching means we are searching an element in a database by using linear search and binary search. So searching algorithm that finds the position of a target value within a list is called a linear search. We are searching elements in linear fashion. That's why the time complexity of linear search is order of n. Then the concept is it sequentially checks each element until a match is found. Then types like linear search, binary search, okay, Fibonacci search. Then binary search uses low plus mid is equal to low plus high by 2. That means we are getting mid position of the element. So then we are checking the element with the mid position. If it is less than the element, then you leave the right portion. If it is greater than the mid position, you leave the first position and search in the next half. That's why order of log n. The time complexity of binary search is order of log n. So finding a student's name in a list of registered students is called a binary search example. Then searching algorithm, like binary search, it uses find the position of a target value within a sorted list. It repeatedly divides the list in half until the target is found. There are two types in binary search like iterative and recursive. Examples of binary search finding a word in a sorted dictionary. Then sorting algorithms like arranging elements in sequential or ascending order or descending order. So there are three types of algorithms here I have listed. Algorithms to sort a list of elements. The concept of these sorting algorithms, they arrange elements in a specific order, ascending, descending. So types like in place, not in place, whether the element is presented or not presented. Sorting a list of numbers from least to greatest, that is called sorting. Okay, then divide and conquer approach uses merge sort and quick sort. So it uses algorithm that divide the problem into sub problems is called divide and conquer approach is a one of the approach in data structures like dynamic programming, greedy approach, and branch and bound. So it solves each sub problem independently and then combine them. It uses recursive method also. Example, sorting a list of numbers using merge sort or quick sort. Then introduction to graph theory. Graph is a collection of elements and connected collection of nodes and connected by the edges in a circuit format is called graph. Study of graphs which are collections of nodes and connected by edges is called graph. Used in network design, routing algorithms, social network analysis, etc. Types of graphs like directed graph, undirected graph, weighted graph, unweighted graph. Examples: social networks like Facebook is the best example for graph application. Can be represented as a graph. Then basic graph algorithms like DFS and BFS. So these two algorithms are traverse algorithms. BFS is nothing but a breadth first search. It uses queue principle. First in, first out. And depth first search, it uses
Stack
stack
principle.
principle. Last in, first out principle are used to visit all the vertices of a graph. Vertices means nodes. Node is a combination of value and address. So you need to have graph traversal types. Okay, like BFS and DFS and shortest path algorithm also we are using. Finding the shortest path in a maze using BFS. There we are using queue principle. Then programming and data structures, when we are using Python to implement and study these structures and algorithms, programmers benefit from the language's simplicity, readability, and vast standard library. That's why the combination of Python with these fundamental concepts paves the way for the development of efficient, scalable, and maintainable software solutions. Introduction to data structures we have explained already. Data structures are foundational constructs in programming that allow for efficient storage. I have explained access, retrieval, and manipulation of data. Three are great advantages, Ramchan. One is efficient storage, efficient access, and efficient manipulation of data. Python offers a rich set of built-in data types. That's why Python is so popular to support these data structures. Stacks I have already explained. It is a linear data structures and follows the principle last in first out. So think of it like a stack of plates, like idli plates, idli container. The last plate you put on top is the first one you are removing. Python can easily implement a stack using list or using collections.dq for a higher efficiency. Then queues are linear data structures and follows the principle first in, first out. So, so here examples like people line of people waiting at bank. The first person in line is the first to be served. Python can implement a queue using collections.tq. Then linked list. List is a collection of elements. Linked list means collection of nodes and connected by the links in one direction is called a single linked list. Collection of nodes and connected by the links in both direction, it is called a double linked list. The collection of nodes and connected by the links, the last node is connected to the first node is called a circular linked list. So Python doesn't have a built-in linked list, but it can be easily implemented using classes. Then tree is a collection of elements and connected by the links in hierarchical structures, with the most common being the binary tree. Python can implement trees using classes with nodes pointing to their children. Then hash table in Python dictionaries are implemented as hash tables. They allow for the fast retrieval of values based on a quick key. Then linear search algorithm checks every element in a list or array until the desired element is found or all elements have been checked. We have seen binary search, a more efficient searching algorithm for sorted list. It divides the list in half repeatedly until finding the desired value or concluding it's absent. Selection sort. A sorting algorithm that works by repeatedly finding the smallest or largest depending on sorting order element and placing it at the beginning. Bubble sort, a sorting algorithm where adjacent elements are repeatedly swapped if they are in the wrong order. Then insertion sort, it follows one item. We are choosing one item at a time by taking one input element in each iteration and placing it at its correct position. Then merge sort. It is a divide and conquer approach algorithm that divides the list into halves, sorts them, and then merge the sorted halves. Then quicksort. Quicksort is a divide and conquer approach where an element called the pivot is chosen. All elements are arranged to make all elements less than the pivot come before and all elements greater come after. Then it recursively sorts the best arrays. Then the introduction to graph. Graph is a collection of nodes. Nodes are also called as vertices connected by edges. They can represent a wide range of problems in computer science. BFS, breadth first search, it follows the principle first in, first out. DFS, it uses the principle stack. It uses the principle called last in, first out principle. So now we will do program. How much time is there,
7
Ramchan?
minutes, sir.
Oh, 7. It's a very big program. Can we see
Yeah,
tomorrow
sure, sir.
this
Sure.
program? Okay. We'll stop
Okay.
here and tomorrow we'll continue stack queue linked list
Sure,
programs.
sir. Sure.
Okay.
Thank you, sir.